theta equal 0 to pi. 0 to pi. Twice of that will give us the lower half also. Total length is this. Now ds d theta, we just calculated. Let me calculate it again. So here ds d theta whole square is equal to r square plus dr d theta whole square. Here dr d theta is equal to, let me take this r, this is first equation, r equal to a 1 plus cos theta. This is nothing but minus a, because a cos theta differentiation is minus a sin theta. Okay, differentiation of cos theta is minus sin theta. This is minus a sin theta, dr d theta. And r square is this value, whole value. Therefore, ds upon d theta whole square. Therefore, ds upon d theta whole square is r square. R square is a square 1 plus cos theta whole square plus dr d theta whole square is a square into sin square theta. This is the value. Okay, so this we have found out. If I take a square common, then again we just calculated this. This will come out as 1 plus cos square theta plus 2 cos theta plus a we have taken. This is sin square theta. Again it is nothing but a square into 2 plus 2 cos theta. Why? Because this sin square theta plus cos square theta is 1. 1 is this, so 1 plus 1 2 cos theta. 2 plus 2 cos theta. And this is ds upon d theta whole square. Therefore, ds upon d theta is equal to a under root 2 plus 2 cos theta. And this we just calculated that what is the value of ds d theta. Therefore, length of the arc here, length of this whole cardioid, length of the cardioid is equal to twice limit 0 to pi into ds d theta into d theta. Okay, so ds d theta is this. We have to substitute this twice a. Let me take a outside. 0 to pi here. Here d theta is square root of 2 plus 2 cos theta whole half d theta. We just calculated this, the same thing we calculated in the previous question, 10th one. Let me take this again, twice a. Now out of this 0 to pi here, within bracket, if I take 2 common, it is 1 plus cos theta whole power half into d theta. Now 1 plus cos theta is 2 cos square theta by 2. So this, let me write here. Therefore, S is equal to total length is equal to twice a. 0 to pi here. It is 2 into 2 cos square theta by 2 or 1.2 theta whole half power into d theta whole half power, and this is theta. Okay, now let me write here. This is twice a. 0 to pi. This 2 will come out into 2 because 2 into 2 4. 4 taken outside. Square root is, this is square root here, half power. Okay, so half power. Square root of this 4 is 2. 2 we have taken outside. In the bracket we will get only cos, because cos is square, so only cos half theta into d theta. Angle is half here, is obtained. Now let me integrate this. Then put the limit. This is 4a, 2 into 2 4a. Integration of cos theta is sin half theta upon 1.2. 0 to pi. This is nothing but 4a into this is twice a twice sorry sine twice into sine, okay, 1/2 theta. For this 2 will come in the numerator, so 2 into sine half theta 0 to pi. It will give us 4 into a within bracket 2 into sine, this is half theta, theta is pi, so this is pi by 2, because sine pi by 2 is 1, but second lower limit at 0, sine 0 is 0, so it is 0. It will give us, therefore total length of the cardioid S is equal to 4a, this 4a into 2 into 1, because sine pi by 2 is 1, 2 into 1 is 2, this is 8a. Answer. First answer is total length of the cardioid is 8a, entire length. It says find the entire length of the cardioid, which is 8a. We know that this length of the cardioid is 8a of this cardioid. Okay, so this is 8a. First point is clear. Now second, it says that prove that the upper half, this one 0 to pi by 3, we know that this half is 4a. Now because total length is 8a, therefore length BA dash, length A B P A dash is equal to 8a upon 2, half of this is 4a, this we know about. Now this length we have to calculate whether this is twice a or not, because total is 4a, half of this total length, half of this is 4a. So this length 0 to pi by 3 limit if I put. Now let me calculate that. So here the same length, so length of the arc AB is equal to, this is just not twice, nothing, only limit 0 to pi by 3, it is ds d theta into d theta. So we know that this is 0 to pi by 3, 0 to pi by 3. It was a square root of 2 plus 2 cos theta. Yes, d theta is a square, we have taken outside square root, and but this is d theta. Now we have to integrate this within this limit. So first question, total length is calculated. Now we have to find out that this length AB arc must be twice a, that we have to prove here. Therefore length AB, length of arc AB is equal to 0 to pi by 3. Now again it is a, it is a, okay, and this is under root of, it will be, let me take 2 common, it is 1 plus cos theta whole power half into d theta. Okay, so limit between 0 to pi by 3 you have to apply here. This is a into, now this 2 into limit 0 to pi by 3, this is 2 into 2 cos square theta by 2, and this half power into d theta. Again it will give us 2 only, this is twice a, this is 2 to the 4, 4 can be taken outside of this square root, it has come out, it will come out as 2, twice a, limits 0 to pi by 3, left over value is cos half theta only. Why? Because this is square root and cos square, so square root is cancelled out. Sorry, this is cos square half theta. Only cos half theta is out of this square root. Now this can be integrated. So integration of this will be, therefore length AB, length of arc AB, length of arc AB is equal to this twice A. Integration of this is sine half theta upon half limit 0 to pi by 3. Okay, so this will give us, let me now find out, this is twice A, it is 2 into sine half theta 0 to pi by 3. It will give us twice A into 2 into, this is now sine pi by 6. Why? So this is half theta. Theta is pi by 3. It will be pi by 6. Sine pi by 6 means sine 30 degree. And 30 degrees of half. Minus at 0, sine 0 is 0. So it is 0. It is nothing but twice A into 2 into half. Since sine 30 degree is equal to half. Pi by 6 is 30 degree. Sine 30 degree is half, we know. 2 to cancel out, only twice A. Therefore, this length is twice A. It means at theta equal to pi by 3, this arc is, this half, upper half is divided into two parts at this point P. Angle value of theta pi by 3 divides the upper half into two equal parts. Total length is 4A. This is twice A. This is twice A. Hence, let me so here therefore at theta equal to pi by 3, okay, the arc upper arc A dash is bisected at B. At B it is bisected, upper half is bisected. This is twice A, this is twice A. Hence proved. This is proved. Hence proved. This we have proved here. Because at A to B this comes out 2A. Total length was 4A. This is also 4A. Total length total is 8A. Hence it is proved. So question number 11, the two parts of this are proved. Because and to show that the arc of the upper half is bisected by theta equal to pi by 3. Upper half, this portion is bisected, means divided into two equal parts at theta equal to pi by 3. This is proved. Twice A comes out. Okay. So question number 11 is finally done. Let me take 12th question. Now question number 12, what does it say? Now it says, question number 12, find the perimeter of the cardioid r equal to A into 1 minus cos theta. Okay, this is 12th, question number 12. Question number 12 is, here cardioid is r equal to A into 1 minus cos theta. Okay, so this is r equal to A into 1 minus cos theta. What the maximum value? This cardioid is solution. You have to find out its entire length. Okay, find the perimeter of the cardioid. With this cardioid, this we traced in curve tracing. This is of this kind of cardioid. Now this starts from here. Okay, so this is the cardioid here. Again, length is theta equal to, here it is theta equal to pi, here theta is 0. If I start from this, so again length is 0 to pi. Okay, so if I start from this, theta is 0 here, and at this point theta is pi. We can again find out what is the length, total length from this to this. If I find this is A point and this is B point, let me take, and this is A dash point, no problem. Length of the cardioid, this is x axis, this is y axis. Okay, but this is at this theta is pi by 2. Okay, now let me find out what is the total length of this theta 0 to pi. If I take, and equation is of this cardioid, or we can take is theta to 0, lower limit, it will be negative value, but here it is theta 0 to pi we will take. Total length of this arc is again ds upon d theta. Let me find the perimeter. So the perimeter, let me take the perimeter of the cardioid is equal to twice limits 0 to pi. Okay, limit 0 to pi, this is ds upon d theta into d theta, because theta here is 0 to limits of theta, therefore this must be differentiated with respect to theta. Now ds upon d theta, as we know, ds upon d theta whole square is equal to, this is r square plus dr d theta whole square. So dr d theta, from this we have to calculate. Here differentiation of first will give us differentiation of first will give us dr d theta is equal to, differentiating this with respect to theta, this is a minus cos theta, so this is a into minus sine, but cos theta differentiation is minus sine theta, so it is minus plus, it is nothing but a sine theta positive. Dr d theta here is a sine theta. Okay, and r is this. Let me write here, this is r square, that means a square into 1 minus cos theta whole square, plus this is dr d theta is a square sine square theta. This value is simple. This is a square sine square theta, and this is a square into 1 minus cos theta whole square. Now let me further solve it. The total length of perimeter of this cardioid we have to find out. Therefore, s equal to, here s is equal to 0 to twice 0 to pi, twice y twice, because this length plus this length, if I take upper half, and twice of that will give us total perimeter. This is ds d theta. So ds d theta is square root of this value. Okay, let me first solve it. So it gives us this ds d theta is a square, if I take common. So first will be 1 plus cos square theta minus 2 cos theta plus sine square theta. It is nothing but 2 minus 2 cos theta. It is, let me take under the square root, it will be a out of the square root, this is 2 minus 2 cos theta whole power half into d theta. This is the value. ds d theta is square root of this. A square is outside, so a is the square root, or we have taken the square root of a, this is a under the bracket 2 minus 2 cos theta, this is minus 2 cos theta, and this is 1 sin theta plus cos square theta is 1, so 1 plus 1 2, 2 minus 2 cos theta. Simple. So this is to be finally solved. So let me take what is the answer of this question. So the answer of this question will give us, is twice 0 to pi, twice a, let me take outside, and again this is within this bracket, let me take 2 common, this is 1 minus cos theta whole power half into d theta. 1 minus cos theta is 2 sin square theta by 2, so this is twice a 0 to pi into, we take 2 into 2 sin square half theta whole power 2 sin square theta by 2. Why? Because we know that since 2 sin square theta is equal to 1 minus cos 2 theta. If there is 1 minus cos theta, then it will be 2 sin square theta by 2. This is 2 sin square theta by 2 because 1 minus cos theta is there. This is trigonometric identity. So from there, 1 minus cos theta will be 2 sin square theta by 2. So this 2 to the 4, 2 can be taken outside, so it will be 4a 0 to pi by 0 to pi, sorry, and this is only sine half theta into d theta. Why it is? Because sine is square half theta, square root is cancelled out, only this is sine half theta. Now let me further integrate this and find the solution. Total length. The total perimeter is equal to 4a. Now this value is integrated. So sine half theta is integrated as minus cos half theta divided by half limits 0 to pi. It is nothing but minus sine 4a. Let me take minus sign out, and this is 4a into twice cos half theta into 0 to pi. Okay, so this is the value here. Or if I take minus sign inside, no problem, this minus sign is there, minus 4a into, or if I put cos pi, first is 2 cos pi by 2, which is 0, minus sign here, then it will be 2 into cos 0, but cos 0 is cos 0 degree, so it will give us 0 here. This is minus 4a, 0 minus 2 only, 2 into 1, because cos 0 is cos 0 degree equal to 1. This is 1 here, so minus 2 to the 4, so it is 8a. Minus 2 into minus 4a, that means plus 4, 8a. Plus 8a, 8a is the length of the perimeter of this cardioid. Answer. Total length of the cardioid, perimeter of the cardioid is 8a, which we have just calculated. Clearly it is there. It is 8a. Answer of 12th question. Question 12 is 8a. And the perimeter of the cardioid is, so total perimeter of this cardioid is 8a here. This answer. Okay. See you in the next lecture then. Next lecture series. This is now completed. Okay. Now this is complete now. Okay. So this is regarding length of the curves in polar equations with the help of polar equations. Okay, this is rectification with the help of polar equations, Cartesian equations, then parametric equations, and this is polar equations we have talked about. Okay, so this is all about polar equations, perimeter, length of the perimeter, length of the arc of the curve given to us. So what is the curve given to us? Length of the arc within a range of the points, so between 2 points where the value of theta or value of the radius vector are given. In that situation, we find out the length of the arc of the curve. This is known as rectification. Okay, so this rectification is, so far as polar equations are concerned, we have completed. Okay, then see you in the next lecture series.